Alright, thank you for clicking on this video, and today what I'm going to share with you is sound null safety, which is the upcoming update to the Dart programming language. So I'm going to link this Medium article down below. So what or why null safety? So Dart is a type-safe language. That means that if you were to have a type for your variables, it wants to be as strict as possible to prevent any bugs that you have in the future. And the thing is, if you were to look at this code, there is a lot of problems because if you were to put in null, then you can have a lot of errors. So you can see that this is a function called print length, and it goes through every file in a for in loop and it prints the file length. So first is that if you were to put a null, and then it will print an error because for the for in loop, it just does not work with null. Second, if you were to put a list and it includes a null, then it will fail because null.length sync will return an error. So there is many cases, and in my experience, that there's a lot of null error that you have to catch. So there is many ways you can catch null, but in fact, Dart is trying to make it as easy as possible for us Flutter or Dart developers to make our code as non-nullable as possible. So we're going to go through a little bit of what null safety is in the future Dart programming language. So you can go to this website, nullsafety.dartpad.dev, and I'm just going to go through all of the exercises that they have added inside this Dartpad. So open it up and we are going to start this simple tutorial. Alright, so if you were to go to the Dartpad with null safety website, then you can click on Learn with Snippets over here on the top right, and then let's choose the first one, Introducing non-nullable type. And then you'll be faced with this bunch of text that explains to you the null safety snippets that you're going to use or you're going to do in this tutorial. So the first thing is that inside our void main over here, if you were to look closely, this seems okay in the current Dart programming language. However, with null safety, you cannot assign a variable into null. So in order for us to make use of this integer variable, we need to assign it to maybe 3 or 145. You can see there is no error. And the thing is that now integer does not take in any null variables. So how are we going to make this into a nullable variable? So let's go on to the next one, which is called nullable types. What if you really want to have this integer to be a null? So why not we put in a very simple question mark. Now you could see there's no errors. So if you were to just highlight over here, you could see that inside our documentation, it has this question mark over here. Now you can see there is no error, and if you were to run this, A is null. So that's pretty interesting. Now let's move on to the third one, more nullable types. So now this is a little bit tricky, but I'll try my best to explain to you. So we have earlier discussed about what if there were a null inside our list or array. So the first one, it looks very, very normal. So you have a list of strings that is 1, 2, and 3. So the second thing is that you can see this variable called a nullable list of strings that's not assigned to anything. So this variable, even though its type is list of string, it's null. However, in the print statement over here, there is an error because we cannot print a non-nullable variable type to be assigned as a null. So how do we fix this? So the first thing is that we're going to use the question mark, but where are we going to put it? So you can try it out yourself, and the correct answer is you put it over here. And then this signifies that this nullable strings, which is the main type list, it is nullable. Now, let's go to the next one. The next one looks pretty okay, but there is a list of nullable strings. So you have 1, you have 3, but you have null. So if we were to put the same position as what we have earlier, does it work? Well, it doesn't, because what this means is that the list is not null, but our elements inside our list is a null. So where should we put our question mark then? We should put the question mark just beside the type of our element. So you could see that the string, one of it might be a null, but the list is not a null. So in our previous variable, this can be a null. A nullable list of string can be a null, or an actual list with elements in it, or an empty list. But the third one says that we have an actual list, but only one of our elements, or maybe in the future there will be a null element. That's why we put the question mark inside the list element type. And now everything should work. So if we were to run this, alright, so everything worked very well. And the thing is, if we don't put anything, or we don't put the question mark, actually all of this will still work. So that's what the difference is between the current implementation of the Dart programming language. So let's go to the next one, definite assignment. So basically what this means is that the Dart type system is crafty, or I would say smart enough to know when the variables are assigned and when the values are read. So this is called definite assignment. So with this null safety feature, so there is an error inside our print statement because our text variable is a non-nullable type. So what we can do is we can uncomment this. And you can see that the print statement over here looks okay because our text is read correctly inside our if-else statement. So if you were to run this, so everything looks fine. So if you were to put it in our normal Dart programming language, currently it has no errors because this text is initialized as a null value. So it will print out null, null.length will shout an error. So if you were to run this, you could see that the first print statement is okay, and then the second one, the print statement, gives us a null. So this is an error that says that we cannot have a null.length. So the good thing about this null safety check is that, for example, if we were to create a null variable, maybe we call it text, and then in the future we are using the text variable, but we might not be able to look forward into the future, and it might have a bug where we did not assign the text correctly. And then if you were to use the length getter method, it will shout an error, and then your Flutter app will just not work. So I've faced this many times. So in order for you to catch the error, you have to make sure that you have a question mark, which is pretty okay. But the thing is, this is just an extra step so that it will print null instead. So that's why I would like to have this null safety check whenever I create variables that is assigned to null first. So the next thing is conditional access. So conditional access is a handy way to tighten up the code that needs to read properties that could be null. So we have created a conditional access over here. So if you were to see over here, if A is null and if you were to put a question mark, it will just return null and it won't run any B function or getter method. So this is very helpful when we didn't have this null safety check. But now with this null safety check, we don't need to use this as much. Alright, so there is a big thing class which has a little thing inside the big thing, and the little thing has a function called fetch int or fetch integer, which just returns the number 12. Alright, so inside the main method we create an instance of a big thing called a big, and this big thing is also a nullable variable. However, this big variable, we need to put the conditional access in order for it to run. So if you were to put this question mark, and then if you were to run this, alright, the value is 12. So the thing is, without null safety, we require two conditional access operators. So the first will be big, and then the second one will be little. So with null safety, conditional access can short circuit, and we will put a single question mark instead. So let's see whether inside the null safety, let's copy this and let's paste it over here. Alright, so we don't have this. Alright, so now you can see that we have this big thing and the target expression uses question mark, so its value can be null. We have a warning over here. So without the null safety, we have to put in both big and little. So the warning will just go away. And then if you were to run this, then it will actually work correctly. With this null safety check, we know that inside this big thing, this little thing will always be okay. because without it, it just doesn't access the big thing at all. So if you were to put this as null, and then if you were to run this, you can see the value is null. So it short circuits everything. If you were to put here null, and then if you were to run this, it's okay. If null question mark, it will go to the next one, and if null question mark, then it will still return null. If we don't put the question mark, then we will have an error because it will still run this a little, and then you could see there is an uncaught type error. So null.fetch integer is an error. So that's why having the null safety check is very good. Alright, so now let's go to the next one. Promotion. Yay, we get a promotion, and congratulations everybody. So with null safety, Dart takes null checks into account. Nullable variables that can't possibly contain null are treated like non-nullable variables. So this behavior is called promotion. So in its essence, basically it means that even though we put in a nullable variable, we will still check the variables that we created inside our function over here. So in order for us to have this null check, what we can do is we can do a very simple if statement. So if the str or string is null, then we return the value 0. So putting the if statement str if it's equal to null, and then we are just going to return a 0. And then if we were to look back and run this, alright, so let's copy this and see in our current version over here. So if we were to implement the same function called length, however, the string is a null, we run this, it's fine because our argument over here is an actual string. But if we were to put null, so there's no null check, even though we know that this will shout an error. So that's why having a null safety check really helps. So let's move on to the next exercise. Promotion with exception. So promotion works with exception. So the only way for you to resolve this problem is to always have a null catch. So we can either return a default value, or we can return an error or an exception in Dart. So let's do that. So like type in if str is equal to null, then we are going to throw an exception. Alright, so exception also you can put in the error message. If you were to just go to exception, there is a message that you can put in. So it's an optional parameter. So let's put in get length param str is null. And then if you were to run this, you could see that we have an exception and we have the error message over here. So having an if statement that catches the null, this will really help in your null safety check, which is really great. Let's go to the next one, the assertion operator. So if you want to assign a nullable expression to a variable that's non-nullable, you can put this bang or exclamation mark. So by adding this after the expression, you're telling Dart that the value won't be null and is safe to assign. However, if you're wrong, so this is a little risky, then an exception will be thrown. So the first one, integer could return null but doesn't. It's a negative. And this is a nullable function that returns an integer. Second is that we have this could be null but isn't. So this is a nullable variable with an integer type that is assigned the number 1. And lastly, we have a list of integer and the element might be nullable. So this list that could hold null. Alright, so how do we do this? Let's go through one by one. So the first one, integer a. So since this is a non-nullable, it cannot be assigned to a nullable type. So we need to put an exclamation mark in order for it to return us the number -3. So if we were to put this exclamation mark, it works. Second one, for integer b, list that could hold nulls, dot first. So dot first is a getter method. So it returns the first elements of the list. So where should we put this exclamation mark? If we were to put right after our list, is it correct? No, it's not correct. So you can see over here, the exclamation mark have no effect because the target expression can't be null. So you can see over here that the list that could hold nulls, this list is not null. But what is a null inside this list? It's element. So the only way that you can use this exclamation mark is in the element itself, which is the first. So any elements that's being returned can get the exclamation mark. And if you were to highlight over here, you could see that inside the documentation, it says integer, which is a nullable type over here. All right, the last one, could return null but doesn't. So where should we put this exclamation mark? Should we put after the absolute function? So absolute, for those who don't know, just returns the absolute value of the integer. That means if it's a negative, it will be a positive. If it's a positive, it will still be a positive. So if we were to put this exclamation mark right after absolute, will it resolve this error? Let's see. No, absolute does not return a nullable integer. It is just a normal integer. So we should put it inside the function that returns us a nullable type integer. And there you go. So if we were to run this and see the console, you could see that A is 1, B is 2, C is 3. Alright, so hopefully you understand this to see where exactly you should put the exclamation mark if you want to assign a non-nullable variable to a nullable variable type. Alright, so you can take a break. And if you don't want, let's move on to the next one, the late keyword. So we have seen the question mark and we have seen the exclamation mark. Now we are going to go to the late keyword. So what is this late keyword? So there is a time where fields in the class can be nullable. Alright, so sometimes you have fields in a class that should be non-nullable but can't be assigned a value right away. So for a case like this, you can put in this late keyword. So it's a way to tell that for your field, you aren't going to assign the field a value right away, but you're going to assign it later. So it's like null first and then we can assign it later. And you make sure that it's assigned to a value before it's accessed. So if you were to create an instance, you'll make sure that the field is assigned to a value before it's accessed. And if you declare a field late, it's read before it has a value, an error will be thrown. So always have it assigned before it's read. So let's try using the late keyword over here. So we have here a class meal with a description. However, this description cannot work because a non-nullable instance field description must be initialized. So we cannot have a null field inside our class meal. So in order for us to resolve this error, you have to type in late. And now our error has been resolved. So we have this set description, where it's a function that just overrides our description into the string that we pass in inside the argument. So inside here you can see final my meal, and this is an instance of the meal object, and then it will set the description of, I'm going to butcher this pronunciation, but feijoada. So it sets the description of your meal, and now let's print it out and see what happens. Alright, so it prints out exactly the string. Now if you want to have a little bit of fun, let's comment out the line that sets the description. So let's do that. You can command or control the backslash, and then it will just comment it out for you. And then if you will run this, and now you can see this late initialize error. So currently our description is not being assigned. So that's why we will have to assign it before we read it. Alright, so let's go to the next, second last exercise. So the late keyword can really be helpful if you have a tricky pattern like a circular reference. Here are two objects that need to maintain non-nullable reference to each other. Try using the late keyword to fix this code. So what do you mean by circular reference? So basically you have two objects and they are referencing from each other. So in a team you have a final coach field, and in a coach class you have a team field object. So let's put in the late keyword. So can we put the late keyword with the final keyword as well? Let's see. Oh, it can. Alright, and then if you were to run this, there's no errors. So when you add a late, do you remove the final? If so, you don't have to. Late fields can also be final. You set their value once, and after that they are read only. So for those who don't know what final is, basically it sets your variable to read only. So this is very good if you want to make it immutable. You want to practice immutability in your project, and this will also help you not to have very weird values that you might not expect. So last one, late and lazy. Like all of us right now in this period of time. Okay, so now there's another pattern that late can help with: lazy initialization for expensive non-nullable fields. So try running this code without changing it. What do you think will change if you make a cache and a late field? So let's go through this whole thing over here. So there is this compute value function that will return the number 3. At the same time, it will print this thing called computing value. So inside this class, there is this cached value provider. So it has a cache with a final variable with a compute value function. So it will return 3. And then this integer getter method. So there is this value getter method which returns the integer of the cache that we have initialized inside the object or class. So the first thing when we run the main method is that we will print this thing called calling constructor. And then after that, we will create this cache value provider instance. And then we will print this getting value. And then we will print out this provider.value. If we were to run this, so the first thing, correct calling constructor. And then when we create this instance, it will say computing value, because how this computing value is being called is inside the cached value provider class. So we will create this final cache variable, which is from the compute value function, which returns this number 3 and then this print statement as well. So in summary, once you create an object, it will run this compute value function. And then after that, we will get the value, and the value is 3. However, once you add a late to the declaration of not independence, but the final variable cache, so put in the late keyword over here, and then you can move the compute value function into the cache value provider class, and the code will still work. So let's see how it looks like right now. Do you see the difference? So let me go through. First, we are printing out calling constructor. However, the second thing, it says getting value. So previously, our computing value print statement is actually called before this getting value. So with this late keyword over here, this means that anything that has to do with the cache, or we want to get anything to do with the cache, will not be initialized first. So this compute value will not run anything because you're not getting the value, which will activate this compute value function. So that is an optimization. And then after that, so we will only call when the object property or getter method is being called. So when .value is being called in this print statement, then it will assign the cache variable over here from the compute value. Wow. So initialization expression for late fields can use to able to use instant methods in their initializations. So this is very helpful for optimization. So you don't have to have an expensive non-nullable fields. So with this, it actually optimizes your code, which the Medium article has pointed out. So with this sound null safety, they have implemented inside their Dart programming language, and they have seen very promising preliminary results. So they have a 19% performance improvement in micro benchmark that emulates typical Flutter framework rendering patterns. So now the Flutter framework, which is already very fast, is 19% faster because of this null safety check, which I guess it makes sense because it optimizes. So you can read this article. I'm going to put the link in the description. And another thing that I want to say is that the null safety is also backwards compatible. So your existing code will continue to run without change. So that's good if you have an existing big Flutter project. So there is no deadlines that they have said over here, which is a very good move, because if you have deadlines, then you have expectation. So you can use it inside the dev channel of Dart. So that will be the tech preview. It will be in beta release where the Dart beta channel has been activated, and it will be in stable release hopefully before the end of this year. So it's pretty exciting to have this out. So that's about it. So if you like this video, give it a thumbs up, and if you want more of this video, subscribe down below. What are you excited about for the Flutter null safety check? This is a very long video because there's a lot of features that you can use and explore in your current Flutter app. So that's about it. Stay safe and all the best. Bye.